In example 2, what we need to do for part A is to show that if we let's just assume we've got these two functions, that if we take the derivative of their product, we get the derivative of the first times the second plus the derivative of the second times the first. So what that means is, let's go ahead and just verify that that's actually true. So f times g of x would be equal to f of x times g of x. So right now I'm going to work on the left side here. Okay, so f of x times g of x is x squared times x to the third, which you guys know is x to the fifth. Now the derivative of that, f times g, the derivative of that new function is equal to 5x to the fourth, like we discussed before. Now let's look over at this side. F prime of x is 2x times g of x, which is x to the third, plus g prime is 3x squared, and f of x is also x squared. We have multiplication here, so this gives me 2x to the fourth plus 3x to the fourth, and I have a total of 5x's to the fourth, so they match. And that's all you have to verify. For part B, it says verify that the product rule works for the following. So let's let f of x be equal to x raised to the m, and g of x be equal to x raised to the nth power, where m and n are natural numbers. So where m and n are elements of the natural numbers. Now the reason that we put this last part in here is because we haven't discussed powers that aren't natural numbers. So if we assume that, well, first f times g of x would be equal to f of x times g of x, which is going to give me x to the m times x to the n, which is x to the m plus n. Now, what I want to do is we want to show that f times g prime of x is equal to f prime of x times g of x plus g prime of x times f of x. So let's work on this guy right here. Well, f times g of x is equal to x raised to the m minus n, so the derivative is m plus n times x to the m plus n minus 1. We bring the power down and subtract 1 off the power. Now let's work on this guy. So it's an ugly mess, but it's not too bad. Let's work on this guy over on this side. Well, f prime is m times x to the m minus 1, and we have to multiply that by g of x, which is x to the n, plus g prime, which is n x to the n minus 1, times f of x, which is just x to the m. I'm going to move my equal sign over so this guy goes here. So again, we don't know that they're equal. That's what we're trying to show, is that they're equal. Okay, so I've already got my left side. Okay. So it's still a question of whether they're equal, so now I need to reduce this side over here. Well, what have I got? I've got m times x to the m plus n minus 1, because you add exponents. And I can change this around, so that's fine. And this is n, so x raised to the m plus n minus 1 again. And now, if I factor out an x raised to the m plus n minus 1, I get the following. I get m plus n times x raised to the m plus n minus 1. And so the two sides are now equal to each other, okay, which is what we were trying to show to begin with.